Hello, everyone. Thank you for joining us today. My name is Megan Balding, and I'm with the USC Viterbi School of Engineering. I'm joined today by Professor Soibelman, who will be speaking to our civil and environmental engineering programs at the graduate level here at the Viterbi School. Again, I want to thank you for joining us and for taking time out of your busy day. Without further ado, we will get started. The first slide today is just a bit of housekeeping here. I do want to let you all know that we will be sending out a copy of the slides after the presentation today, so you don't need to worry about making notes or copying any of the information down. We will make sure to get that over to you within the next few business days. Additionally, at the end of today's session, we will have time for question and answer with Professor Soibelman. So please do send your questions throughout the presentation. We'll gather those and use them during the Q&A session. So any questions that you have on the programs, on the department, really anything that might be a burning question that you have, we really do encourage you to send that over, and we will address it at the end of the session. You can use the Q&A panel on the right of the presentation to ask those questions, and we will monitor on our end. So today's program will quickly discuss the University of Southern California and the Viterbi School of Engineering. We'll then pass the presentation over to Professor Soibelman, who will talk about our graduate programs in civil and environmental engineering. I'll then speak briefly to Den at Viterbi, our online delivery, and go over our tuition and fee structure. And then at that point, we'll pass the presentation to all of you, who can then chime in with any questions that you do have. If you've never been to the University of Southern California, we've provided some campus images here for you to get an idea of what the campus itself looks like. We are the oldest private university in the western United States. We were founded in 1880. We currently have about 44,000 students with about 19,000 undergrads and 25,000 graduates. We have just under 4,200 full-time faculty and a diverse student population with students coming from over 100 countries in all 50 states. The campus itself is located in downtown Los Angeles, or just south of downtown Los Angeles. So it's a really great position to be close to everything that's going on in the downtown area here in Los Angeles, as well as kind of the greater LA area, the Aerospace and Defense Corridor in El Segundo, Silicon Beach, which is a growing area in the beach areas. There's just so much that goes on in Los Angeles, not to mention Southern California at large. The Viterbi School consists of 8 academic departments. We have 185 tenure-track faculty, of whom over 20 are members of the National Academy of Engineering, and over 60 have received the National Science Foundation Career, National, and Presidential Young Investigator Awards. We currently have over 65,000 engineering alumni, and our current student population is just around 2,700 undergraduates and 5,600 graduate students. The Viterbi School is considered a leader in funded research with over 45 research centers and more than $185 million in research expenditures annually. The next slide just quickly touches base on some of our recent rankings by U.S. News & World Report. We're consistently ranked the top graduate engineering program overall by U.S. News & World Report, and our current online graduate engineering programs are ranked #1 overall, as well as for our computer science program. We share those #1 rankings amongst the rankings for veterans as they relate to veterans as well. We have a very strong international reputation for excellence within the Viterbi School of Engineering. Much of that has to do with the research that goes on here and our amazing students and faculty that really provide a name for not only the University of Southern California, but also specifically within the School of Engineering. I mentioned the 65,000 engineering alumni. We refer to that as our Trojan Family Network. The Trojan Family Network really provides individuals, whether you're a current student or alum, with the opportunity to connect with individuals no matter where you may be in the world. So while we are located in the Los Angeles area, our alum are located throughout the world and have active alumni networks, pretty much in every major city. So no matter where you may find yourself, whether you're right here in Los Angeles or halfway around the world, chances are there's a way to connect with the Trojan family from your location. We have engineering programs that are available online, on-site, and on campus, and they range from PhD, master's, and bachelor's programs. To clarify, the online programs are at the master's level. Our on-campus programs are, all of our graduate level programs, and our on-site programs are specific to the executive education sphere. So with that said, we have our, of course, doctoral, master's, and bachelor's programs, our graduate certificate programs, which are about half the units of a master's degree, and of course we have executive education, short courses, and custom programs. As I mentioned, the Viterbi School is a consistent leader in funded research in the United States with our over 45 research centers. We have a very highly interdisciplinary research environment with research areas such as robotics, software engineering, sensor networks, vision sciences, automated construction, and photonics. One of the real strengths of our programs and our research is the industrial partnerships and collaborations that we have with local and, companies that are not just in Los Angeles, but located around the world. So without further ado, I'll pass the presentation over to Professor Soibelman. Professor Soibelman is the Viterbi Dean's Professor and Department Chair. He received his doctoral degree from the Massachusetts Institute of Technology, or I could have said MIT to make that shorter. And we do have a number of your research areas listed here, including artificial intelligence, data mining, and a number of other areas that I definitely am not the expert in. So I will let you take over the presentation from this point. Thank you.
Okay, so welcome everyone, and it's a pleasure to be here talking to you all. I will talk a little bit about the master's programs, and then should be talk a lot of PhD too, so talk about all the graduate programs. So when you think about the expertise of the faculty in the research, we divide ourselves in 4 main areas. So this is very relevant for the people that want to do PhDs. We have a group that's called the Extreme Events Group that goes from wave propagation on soils to understand the behavior of earthquakes. We have the health monitoring people that looks into the behavior of buildings and infrastructure systems during extreme events, wind and earthquake and flooding. And then you have the group, the tsunami group and the coastal engineering group that it's very, very strong here. The second main area that you have is the sustainability group. The sustainability, you have top people in air quality, impact on health. This is a huge strength that we have a lot of grants working with Department of Health and other things, trying to understand how polluted highway systems are affecting health of people living around highway systems. But you have people looking into what you call heat islands, understanding how cities, mega cities like LA's are creating microclimates and contributing to global warming. And within the sustainability group, you have people from the construction group that works with smart buildings. That's me and others that we look into energy efficiency and advanced controls to make smart buildings and smart infrastructure. The third area that you have, it's water quality. You have very good research in both in water chemistry, microbiology, and advanced research on membrane systems for desalination and wastewater treatment. And the last group, it's what we call the systems of systems group that try to look at the domino effect of large infrastructure systems. So if you think that we civil engineers got very good in optimizing our infrastructure, but we do it as independent systems. The example that I use is that you have water main systems that you optimize to bring water to your house, and you have transportation systems that are designed to optimize the time to travel from one point to another. But when you have a water main breaking, you flood the highway, and both systems stop working at the same time. So you don't have a lot of understanding about this domino effect when one system failure affect the other system. You have some feeling that you understand when the electrical grid stops working, you stop the transportation because the lights and the dispatch systems and trains don't work. So you understand that all those things are coupled, but you really don't know how to model them well. So this is the strength in research. If you go to the master's side, you have a lot of different masters, okay? You have the masters in civil engineering, the masters in civil engineering, construction engineering, the civil engineering, structural engineering, and the transportation engineering, transportation systems. water and waste management, the environmental engineering, and the construction management. So, and then the graduate certificate in transportation systems. So those masters are very different one from another, and you can go to the homepage and you have in the slides a lot of description of curriculum and what is expected to take for those things. But the most important thing for you to understand is that some of those masters are more related to industry, and others are more related to science, okay? So let me explain the example. For example, the masters in construction engineering, it is a very, very strong program that you have. It's a large program with more than 100 students, and it is not just taught by academics like me, okay? What you are in a big city like LA, and you have amazing construction companies around us. So you have the biggest construction companies in the country that are located locally with offices, Arup, ACOM, Jacobs, and a lot of engineering companies, a lot of large construction companies. And many of those companies have amazing staff that have a very high level of education, many with PhDs, and maintain a network with the university. So you use them as a resource to teach many of our classes. So they teach the director of, the vice president of scheduling of one of those large companies teach scheduling, the vice president of another large company teach the estimating class. So they bring exactly the way that they do in a very practical way. They do it because there is a law for teaching, but they do it too because they want to hire our top students. So there is a two-way interaction in that. But the important for us is that the academics like me, David Ashley, Hank Kaufman, Burchin Besterik, and Dave Gerber, that are the more professors in this area, we teach the vision for the future. We teach how things will be done in the future, what is changing in the industry. But the people from industry keep us grounded. They teach, look, you can dream, okay? This is robotic in construction some years from now, but these are the problems that we are facing today. These are the problems that those students need to solve. So it's a very interesting program, and the students already build a whole network with large construction companies. So the same thing happened with the transportation engineering and transportation systems. We have a lot of people from Caltrans, from the airport, LAX, from the port of LA, that are here teaching our students about the practical issues at the same time that we have academics teaching the academic part. The environmental area, the environmental engineering, it's more academic-wise. You have more academics, but you still have people from industry teaching. They teach what you call the capstone design, the last classes that the students have to put everything that they learn together. But again, the masters in environmental engineering, it's pretty interesting. We use two areas of concentration, water and air. Water quality and air quality. The interesting thing that the students in the water area have to take some classes in the air area, but the students in the air class has to take some class in the air. So they learn both things, but they keep their focus in one of the areas. The structural engineering, it's pretty interesting too. We have two areas that the masters split itself. One is more in the mechanics, and the mechanics are more in the academics, understanding the math and the mechanics, and you have the concentration more in design, and the design is really brought by people from industry that are structural engineers in large structural engineering firms locally. We can do this because you are in a big city. This is a strength in our program if you compare our program with masters that are delivered in small campus towns that are beautiful campus, beautiful universities, very good universities, but they have to organize their masters in different way. They have to do an all-academic program because there is no industry around them, okay? They are very good programs, not criticizing those programs, but they are different. You really need to know what you want. And this is what I consider that can make us different, is that we are in a huge city with millions of people, large corporations, that you can use them to teach something that others in schools can't. The Masters in Construction Management, it's the only one that's a little bit different. You have a lot of people that have no background in engineering that want to learn construction management. So this Masters is targeted for students normally that don't have engineering degree as an undergraduate student. We cannot get a student that has an undergrad in architecture and give a degree in engineering unless these students go through extra courses that you call leveling courses. We cannot. There is a responsibility that we have as civil engineers. If you give a title for someone because took some class in scheduling, estimating, give them this person a title of engineer, this person can use this title and you start designing buildings. So there is a social responsibility that you have. They can kill people if they do this. So normally to allow a non-engineer to take our masters, they have to take some leveling courses to be able for us to feel confident that this person can indeed talk and work as an engineer. But many things that we do in construction management, it's much more soft. It's much more related to management, like dealing with workers, scheduling, estimating, planning, and those kinds of things that we do. So we receive a lot of interest from people that don't have a degree in engineering, so we don't give them a degree in engineering. We give them a degree in management. And the same thing in the environmental area. We have a degree that we can give to students that it's a master's in environmental management too. That is, we don't give the engineering degree, allowing those students that want to move, that come from other areas and want to move into that area, they can without having to take an extra 1 year of courses to be able to get the engineering degree. So you have both. You have master's students that seize the opportunity to get the engineering degree and take those leveling courses, but you have students, no, I just want a job in this area. It's an area that I love. I just want to get some expertise and I need just a degree, and we give them the management degree. So I think that this is the short description of everything that we do in our masters. What is the difference from our masters to other large universities that have very good programs too, but what makes us different. And so with the following slides, you have more explanation about the classes, the curriculum, what is to take, but this is not the most important thing. You can find this online. And to tell the truth, you are doing now a huge curriculum upgrade. You are rethinking. We are always doing this. You're always thinking how to move forward, and we are never static. So even those things that you read online, there is always the risk of you're arriving here and you are evolving and changing things, because we have to evolve. We never stop moving.
Great. Thank you, Professor Soibelman. So as Professor Soibelman mentioned, we do have a number of slides here. Again, if you are joining the session late, we did mention at the beginning that we will be sending out this slide presentation to all of the attendees, so you can review this in your own when you do have time, if you're interested in kind of getting an idea of the courses. A couple of questions that I was going to ask now, if you don't mind. One question we often hear is, what is the difference really between the transportation engineering versus transportation systems? Not so much the difference, but why would someone choose to go into one versus the other?
That's not even something that it's important when you apply, because you can move from one to another. But you can go back to the slides and you're going to see that there are some classes that they take. Transportation engineering, okay. So you have these 18 units. There are more units in environmental, in the civil engineering, okay. And then if you go in the systems has more classes outside civil engineering. more at the urban planning, and one it's much more the engineering side of transportation, how you optimize things, how you make the trains run on time, how you design the systems, and the other brings the policy. Okay, right. Brings the planning, the law, the management. So the difference that one is a little bit more engineering, and the other is a little bit has on top of engineering more soft issues that come from the Price School of Policy. And we are indeed working now to build a third program, that's the Transportation Systems Management. That would not be an engineering degree, because we have a lot of people that are coming from other domains that are managing transportation systems, and they want to learn them.
Great. Someone attending just asked, what is the difference in water and waste management and environmental engineering courses?
The water, it's a little bit more, the water group, it's a little bit more the engineering side, where you are learning to design channels, and you are learning how to design pipelines and the vessels. Okay, you are really not learning the quality of the water. So the environmental side is to teach more how to treat water for you to drink, how to clean wastewater, basically how to reuse wastewater, and all those discussions that is typical, both chemistry, biology, and the environmental side. You go from chemistry, biology, and a little bit of physics with the membrane systems, understanding the behavior. But the water program, it's much more really the engineering, how the dimension of channels and drains, and they focus a lot in coastal engineering too.
I would take it a question on the difference between construction engineering and construction management, but I think that came in after you had started talking, or before you started talking about it. Well, one of the questions here, and this might be a good transition, is do you have a PhD program in construction management or construction engineering? Or, what would someone want to do?
So the PhD in this area, PhD is something that the website is never going to be updated, because you don't do a PhD with a department, you do a PhD with a professor. So the best way of finding out how to do a PhD is not to look at departments, you look at professors. You read their papers, you read what they're doing, and you say, I really like what they are doing. So the main research that you have now within the construction people are not in traditional construction management. Okay? We are not doing research in productivity, in scheduling, in safety, traditional way at least. I am, for example, I am one of them, so it's me. Basically, the most active faculty in research today in the construction domain in the department, it's me and Burcin Basarik. I work with what we call data-rich environment. So we looked at construction sites generate data, so I try to learn about why a project's behind schedule, just looking at the data that they are doing from the control, trying to find cause and effect relationship on data. I moved a lot into sensing, because people are adding sensors on site, sensors on buildings and infrastructure, how you predict if your car tells if the temperature of the water is high and you stop driving because you don't want to destroy your car. I would love bridges that you tell, don't drive over me, I don't have the right capacity to deal with the load. So having infrastructure elements, both, I look at the whole life cycle, not just construction anymore. Burcin works, again, in construction, we're working a lot with drones, creating models and trying to find out if the project is behind schedule or on time. So you use laser scanners, so you're using advanced technologies to acquire data and to do analysis. Burcin works in what we call human-building interaction, so she's trying to understand how people behave on buildings. So in construction, she's looking into how humans are going to interact with robots. If you have a bricklaying robot working side by side with a construction worker, how we are going to have this interaction and make it safe, not the person to die under the robot, and at the same time how to increase the productivity of them together. She works a lot with energy-efficient buildings, but not the buildings that make decisions to turn off the lights and you have to jump and raise your hands because the sensor doesn't realize that you are in the building, but buildings that really optimize the energy consumption with the woman, the man and woman in the loop. So when you have 5 people in a room, how do you set the thermostat? So working with iPhones and smartphones and allowing people to interact and give and bid and give their comfort zones and the control systems finding the optimal temperature that would make almost everyone comfortable, but at the same time energy efficient. So you have a lot of very advanced, but the best way to find about research is go to the homepage, find the faculty, read their papers and say, this is boring, I would never want to work on that. Good, no problem. This is something that really excites me, and this is for every university.
Great. Perfect. Thank you. So I think that provided a really great overview, too, of the PhD program opportunities here. What about individuals that are maybe haven't decided whether a master's or PhD is the direction they want to go? What would your advice be to those individuals?
Start with the master's. Okay. It's always an idea. If you don't know, you can start with the master's and try. It's not so easy, but you have to be smart on that because the master's program has a higher load. So the students tend to take too many classes that take their whole time, and then they don't have time to really start interacting with professors doing research because they have their hands full. So this is something that you have to plan and decide that I'm going to take one less class in the first semester. I want to interact with Professor X and Y. Professors are really very welcoming to bring master students, not funding because the student is not dedicated full-time to the research, but students that are investigating, do I like to do research? It's a good opportunity. They go and they start interacting with the professor, start to be part of the research team, interact with their PhD students, talk, and learn if they like. What I say about research and industry, it's nothing to do with intelligence. People say, oh, that person is very intelligent, got a PhD. It's a different way of seeing the world, okay? I was in industry for 10 years before coming back to academia. In industry, I wasn't happy because of the way that I think. I'm always thinking, how can I do things differently? I would go to a construction site and I look at a wheelbarrow and say, why this thing has one wheel? And I start designing wheelbarrows, and everyone say, you have a project, 50 floors to deliver, and you are designing wheelbarrows? And again, industry, you have to focus, you have to deliver. You cannot dream, you cannot ask things. And in academia, we can always look at things and say, I would like to do this different. And then you stay 5 years trying to do it different. And then it doesn't work. Okay, go to the next. No problem, but it's a level of curiosity. And you are paid to be curious. So, but again, if you're not curious, if someone that really come to a PhD expecting your advisor to tell what to do every day, you're going to be very unhappy too, because you're someone that wants to go forward and don't want to stop and think and ask. So it's just a question of being a different person, different way of seeing the world. And this is why starting with a master's and start interacting with researchers saying this excites me or this makes me really, really bored and I don't want to do it. So it's a good opportunity.
Great. Well, I do have a couple more questions coming in, but what I'll do is hold those up until we get to the Q&A at the end here, so we can get through a couple more slides, and that way we can devote as much time as possible to the Q&A. As far as application criteria, generally for all of the programs, you can go to our website for more information. Each program does have its own unique requirements. Overall, though, for any of the MS in civil engineering or environmental engineering program, an undergraduate degree in engineering, math, or hard science from a regionally accredited university is required. as Professor Soibelman mentioned, the Master in Construction Management is a bit of a unique program. That program requires an undergraduate degree from a regionally accredited university, so it doesn't have to be from an engineering background, but it does ask for some training in capital management and statistics. If you don't have an underground background that satisfies the course prerequisites, then you'll work with the department to figure out how to fulfill those deficiencies. Generally, we're looking for around a 3.0 cumulative GPA on a 4.0 scale. The GRE is required for all degree programs. Resume is required. Supplemental materials like letters of recommendation or a statement of purpose will depend on the program you're applying to, and international applicants will need to look into submitting scores for the TOEFL exam. As far as upcoming application deadlines, so this information is for the master's level programs. If you're interested in the doctoral program, there is a bit of a different process as far as the background requirements, and you will need to abide by the December 15th for funding opportunities deadline. I do encourage you to visit our website. There is a faculty search function now, faculty research search function, where you can type in maybe if you already know some areas of interest that you have research-wise. You can type in, key terms and find more information on related work being done here at the School of Engineering. So I encourage you to look into that, especially as you start to explore doctoral programs. As far as application deadlines, the deadline required for all materials for fall of 2018 is January 17th. If you are interested in scholarship consideration as an on-campus student or for the doctoral program, the deadline is December 15th. Spring 2019 will be the next available application period. That deadline is going to be September 15th, and again, a little bit earlier for scholarship consideration. Doctoral applications are only considered for the fall. As a Viterbi applicant, that's our online delivery. We do sometimes have, or we do have the ability to provide an application extension, so please do email us for more information. So one of the questions I had, or that we often hear, where are your alumni going from the master's programs? What kind of positions are they going into? What kind of companies are they working for?
Everything.
Right.
So it's a difficult question. I'd say that the construction, the students end up in large construction companies. We have already direct connection through the companies that are even with their members teaching at the program, as I said before. So it's very common for all our students to get jobs even before they finish the first semester, and they start interacting with those faculty that introduce them to their companies. The economy is good now. I don't know 2 years from now, but again, that's not a promise, but this is what's happening today. In the environmental side, you have the students going everywhere. You have in the environmental side, the students working for non-government agencies, the students working for government. You have the students working for engineering companies that are doing environmental impact analysis. You have the students going to every possible direction. Transportation students too, but they get jobs with Caltrans, government agencies, but many are working with design companies. There is a lot of design going on for the high-speed rail, for the metro, LA Metro, so there are jobs that they cannot fulfill. So a lot of students are working either for design companies or directly to the agencies. Structural engineering, it's the one that it's more narrow. The students work for structural engineering companies. But again, there are so many different areas, so many different positions, and our students are very successful in doing what they want. There are the students that want to make money. There are the students that want to change the world. All of them find their group and find their happiness.
That's what we like to hear. All right, so the next couple slides will just briefly talk about our course delivery options at the master's level. As a master's or prospective master's student, you have the ability to look at, two options for a couple of the degree programs. All of the programs are, of course, available on campus. Most of our on-campus students are full-time students taking around 3 to 4 classes per semester. It takes about 1.5 to 2 years to complete at that schedule. There are a number of degree programs within civil engineering that are available online via Viterbi. Generally, these students are working full-time, but you don't have to be. With that said, they're taking around 1 to 2 classes per semester and then taking about 2.5 to 3 years to complete their degree program. I won't get into all of this again. We'll be sending out the slides for you to review at your own time. But Viterbi does provide individuals with the opportunity to pursue their degree program completely from a distance from anywhere in the world. It enables you to either view the class live that's happening here on campus or on demand at a later time. You're viewing the same lectures as your on-campus students with fresh content every semester. You're submitting your homework electronically. You have the ability to interact with discussions with professors and peers, and exams are done at proctored testing centers near your home or office. The following chart goes over some of the similarities and differences between our on-campus and Viterbi students, but ultimately we hope you see that where it really matters, where it's program admission requirements, the assignments that you submit, the exams that you take, everything from start to finish is going to be exactly the same. You're held to the same standards when you're applying and the same standards to complete the degree program that you're admitted to, so ultimately the diploma that you receive is exactly the same. This image provides you with an idea of how integrated the classroom really is. This is a Viterbi classroom. We're seeing it from the perspective of the camera operator. This is an individual that sits in on every class that's being provided via Viterbi. This enables the camera operator to really capture everything that's happening within this classroom setting. What's able or open to some of our on-campus students is the ability, if you are registered in a class with a Viterbi section, you can then also view those classes and lectures as a review tool later in the semester. So definitely a nice benefit for all of our student population. A quick snapshot of our e-learning system, so you can get an idea of how that works. Definitely as a DEN student and for all of our students, you have access to a number of different tools that you can utilize as a student to connect interactively with other fellow students, whether you're all here on campus or, some here on campus and some located in other parts of the United States or even around the world. So ultimately, we hope you see that there is no difference between earning your degree on campus or via Viterbi. It really is just a delivery method. So a couple of quick items specific to Viterbi, and then we'll get into our last few slides and focus on our question and answer. Limited status allows strong candidates to begin coursework before formal admission. You are able to take up to 12 units as a limited student, which can be applied toward a degree program once admitted, but limited status does not guarantee admission. Ultimately, what this allows you to do is to get started this spring. So if you're interested in pursuing your degree program as a Viterbi student, you can get started this spring 2018 and qualified for a limited status. So for more information on the qualifications and how to get started, you can visit the link here. Tuition deferment program. Students that are being supported by an organization can defer the upfront payment of tuition until after the semester is over. In order to be eligible, your company must be paying 75% to 100% of your tuition. And the following is an overview of our tuition and fees for the current school year. Tuition for 500 or 600 level course, that's a graduate level course, is $1,937. You can see the cost for a 3-unit versus 4-unit course there. There are additional fees and items to be aware of where you can visit a very thorough overview of this. You can visit our tuition and fees page for our master's program. And so the following is just next steps on how you can apply and get started, depending on your preferred delivery method. So at this point, Professor Soibelman, we do have a couple of questions that have come in, and please do, for those of you attending, send over as many questions as you're able to. We'll look at addressing all of those as soon as we can here. So let's see here. I've already asked a couple of these. Give me 2 seconds. I saw one about funding that I just must have passed by. Okay. Is there departmental funding or TA-ships available for doctoral students? And, basically how does that funding aspect work for the doctoral students?
Okay, so all PhD students are funded. Okay, there are some students that come with funding from their own government and everything, but this is why I say that the student have to talk to the professor. There are basically two ways of going. One is there are fellowships. They're a very small number compared to the population that we bring, and then there are the professors that have their grants. And professors at their grants hire the students to deliver the research for the funding that they have. So I write a proposal to National Science Foundation. I'm going to come up with a new scheduling tool for construction, and they give me the money. Then I hire the student to help me deliver that thing. And I look at the CV of the student that have the background to be able to work with me in that area. So the main issue here is we don't know what are the numbers for admission. That's different than the master's. The master, if you have GPA above these and everything, you can go and admit. For the PhD, it's a competition. So I receive 50 applicants that want to work with me, and I don't know now how much money I'm going to have next year, so I'm writing proposals. By next year, the director of NSF is going to call me and say, oh, I'm not funding this, but I'm funding that. So I get an idea of how much money I'm going to have, and then I start hiring, and then I decide I can hire one, I can hire two, and then I look at all those 50 and I choose the two that are best match for the research that I want to do. For the fellowships, it's even more complex because the fellowships, because we have a small number of fellowships, we don't have, again, a number to tell how much it's needed to be admitted because we rank all the candidates. So if you are very, very good, but there is someone that is even better in the pool, that person is going to be ranked first. There is a criteria, obvious, that it's not just GPA. If you have a 4.0 GPA in a small unknown university, doesn't mean the same thing as a 3.9 GPA at Harvard. So it really depends. We know the universities out there. We are an international university. You have students from all over the world, have data from the past from students from different universities. And we basically rank the students, and the ones in the top are the ones admitted. So there are both fellowships and straight interaction with faculty. So the easiest one is, interact with the faculty, read about the faculty, get interested in the faculty work, and see if the faculty has the funding to bring you. If you're really, really a superstar, yes. If you're a superstar, you have a chance of getting the fellowship.
Great. And I know just I believe a number of you out there are interested in our master's level programs. And just so you're aware, because this is a question we often receive on master's level funding, that funding really does go toward the doctoral students. So when you're looking at funding opportunities like TAs or RA-ships, that is going to go toward the doctoral student population. The master's level, the tuition, the funding opportunities are quite limited. So it's just something to keep in mind. And if that is something you're interested in, as an on-campus student, you'll want to pay attention to those scholarship deadlines so that you do qualify for being reviewed towards any available on-campus scholarships. And as a Dena Viterbi student, we do have specific scholarships for our Dena Viterbi students. So definitely something you can look into and ask questions on as you get a little bit further into your program or application process. One of the questions I had for you, Dr. Soibelman, is, you do have the graduate certificate in transportation systems. Why would somebody do that program versus going on to or doing a full master's program? Why would they, or if they do both of them, why would they start with the grad cert? What is that population that would look into the graduate certificate?
I don't know exactly why these students do that. It's their decision. But I have that because there are a smaller number of classes, it's a little bit cheaper. So I think that the decision is basically a cost decision. Someone that wants to look for a job and want to get some title in the area to be able to get the jobs in the area without investing the whole budget that costs for the whole money that costs for a master's. So it's an opportunity to take less class. I think that's a little bit more flexible to choose the classes and which classes to take. So it gives more flexibility for a lower cost, and still it's a degree that would help them to get the jobs that they want.
Great. And then a question I just had a couple of days ago was someone was interested in the Master's in Construction Management program, but they were also looking at, a real estate development type program, and they were wondering what were the benefits of maybe going down the construction management Master's program versus, looking maybe more towards a policy program, ultimately.
It's very personal. It's very personal, yes. What I would say that depends on what you want to do. I think that the best way of answering those questions is not asking professors, but asking the people that you want to work for, okay? So if you have your company that you consider to be your dream company, that I would love to work for that company, go to them and say, to their human resources department, and say, what are you looking for the people that you are going to hire? What is the expertise that you think that one of your star hires has? So it's knowledge in policy or it's knowledge in management, in engineering. So they say, oh, this person has to have this. So you go and you take wherever it's needed for you to get your dream job. Those are different products. Those are different students, and will open different doors for you. So you basically have to decide which doors that you want to be open.
Great. Well, I think that wraps up the questions from today's session. So I do want to, I'll leave it on this slide. So if you do end up having further questions, you can feel free to email, call us. Please do visit the website for more information on applications and program information. I mentioned the ability to search the search function for the faculty and research. I encourage you to do that if you're looking at doctoral programs as well. So thank you, Dr. Soibelman, for attending today and for sharing all the wonderful information on our programs. We really appreciate it. And to all of you that joined us today, I really do appreciate you taking out the time out of your busy days to learn a little bit more about our master's and PhD programs here at the Viterbi School within Civil and Environmental Engineering. So thank you so much, everyone.
Thank you, everyone. It was a pleasure talking to you. And if you have more questions, you can send me mail. You will find me in the internet if the information is not in these slides. But feel free to send me mail, and I can either answer the question or at least forward you to the right person.
Thank you.